Alright, for the second problem, we're doing another interval convergence equation, well, problem, and we're trying to figure out if it converges or diverges. So I want you to keep in mind from the last video that if the limit of this integral is finite, it converges, and if it is not, meaning it's infinite in either the positive or negative direction, it diverges. So here we have a type 2 improper integral, which means that one or two of the bounds are infinite. And in this case, one of the bounds are infinite. So we're going to have to rewrite this as a limit. So the limit as b approaches infinity, which basically means you're going to just set your infinite bound to a variable just to look at it in a different light. So the limit of x and sine of x squared with respect to x from 0 to b is your new integral. Now the sort of easy part, the integration method. Now for the last video, I mentioned how I have this hierarchy of cascading integration methods that I use, which basically means it helps me choose which integration method to use. It starts off with direct integration, then u sub, then integration by parts, then I'll go on to trig identities, then trig sub, and last but not least, or very least, partial fractions. And this basically means that if direct integration does not work, I go down to u sub. If that doesn't work, I use integration by parts, or at least try them, until I find something that works. Now, this particular problem, direct does not work, just like in the last problem. Now, this one, let's try u sub. U sub, it's key to notice if the derivative of something in your function, exists in the bigger function. So in this case, we have x squared. What's the derivative of x squared? 2x. And x is here. So that means at some point in time, x's are going to cancel out. So I'm going to say u equals x squared, and the derivative of this is 2x dx, which is going to be rewritten as du divided by 2x equals dx. Because this will be plugged in for your dx, which means this x and that x will cancel out. I'll write it all out for you. The limit as b approaches infinity from 0 to b of x sine of x squared du divided by 2x. That x cancel out, that x cancel out. So now we have the limit as b approaches infinity from 0 to b of sine of u. And I'm sorry, this should have been a u right here, because I already plugged in my u values. Sine of u with respect to u. So now we can integrate. The integral of, oh, and don't forget your 1/2. I'm going to put the 1/2 right here. Let's add it there, divided by 2. So now when we actually integrate this, we're going to end up with the limit as b approaches infinity of 1/2 cosine x squared. And actually the integral of a sine is going to give us a negative, so we'll pull the negative out here. Negative of 1/2 cosine x squared from 0 to b. So let's actually write this integral out now. The limit as b approaches infinity of a negative 1/2 cosine b squared plus a 1/2 cosine of 0 squared. Now let's look at this cosine b squared, which means we're going to plug in a infinite bound for b, which means this will be rewritten as negative 1/2 of cosine infinity squared, the limit of this. Now I want you to think about the graph of cosine. It oscillates between 1 and negative 1, which means as it goes to infinity, as all x values go to infinity, it's still oscillating. There's no finite value for the cosine of infinity. So that means that limit is infinity. Now we still have this, which is going to become plus 1/2 because cosine of 0 is 1, so plus 1/2. Bring that down. So we have infinity plus 1/2. Infinity plus any value minus any value multiplied by any value is always infinity. It just means that the rate of it is increasing even faster than just infinity. Now let's recall what I said earlier. If the value is finite, it converges. If it's infinite in the positive or negative direction, it's divergent. this particular problem, we got an infinite answer, which means that this diverges by all means. So this equation right here is divergent because it's going to infinity.